Okay, so in section 4 of chapter 4, so 4.4, okay, let's first turn our attention to this sideboard over by me, please and thank you. If you look under Wednesday, my dudes, the 28th of this fine month of November, under honors geometry, this bottom one. SWBA, what's SWBA stand for? Students will be able to, you guys will be able to, by the end of this period, use CPCTC, you'll figure out what that means in a second, to find sides and angles, which is section 4.4. Hey, speaking of CPCTC, it says here, congruent triangles and understanding CPCTC. And it says, corresponding parts of congruent triangles are congruent. So that's where the abbreviation comes from. We leave out the of and the are in our abbreviation, and we just make it CPCTC.
Did you come up with WBCD vote?
No.
Do you know what that means?
No.
Why your or you know why ours?
There's an abbreviation thing for
Okay, voices off, please. Congruent figures. Congruent figures. So we know about congruent sides, congruent angles, those different things, okay? So we have congruent figures as well. So we're going to define that as having the same size and shape. Same size and shape. And that corresponding sides and corresponding angles are congruent. That's how we'll define congruent figures. So we'll say two figures are congruent if they're the same size, the same shape, which means that their corresponding sides and corresponding angles are congruent as well. So we have what we call a congruent statement. A congruent statement. So we have congruent statements for saying that like angle F is congruent to angle A, for example. Or we could say that segment AB is congruent to segment FE. Okay, we could say different things like that. That would be a congruent statement. It's a statement that says it's congruent. So congruent statements for shapes, we have to be really careful with the order we put these in. So here we see an example, triangle ABC is congruent to triangle FED. Well, we have to be careful with the order we put that in because we first have to say that their corresponding angles are in the same order. So we first have to figure out, okay, what are corresponding angles? Well, corresponding angles and corresponding sides are going to be the ones that are kind of in the same spot or have the same measure. So angle A and angle F, for example, we know they're congruent how? Okay, because of the arcs. How many arcs does angle A and angle F have? One. Are there any other angles with only one arc? No. So those, angle A and angle F. So those are congruent. So we put A first here, and because we put A first here, we have to put F first here, because those are congruent angles. And then if we put B next, well, which angle is congruent with B? E, because it has two arcs as well. So we have to put E next, because we put B next. And so C would be our last one, which has how many arcs?
The thick boy.
3 is the thick boy, okay, with 2 C's and a few I's for the boy. Okay, and angle C is congruent to which angle? D. So we put D at the bottom there. So we could also write it, let's actually write those corresponding angles first. So we said angle A and angle F are corresponding. We also said angle B and angle what are corresponding?
E.
E, very good. And we said angle C and angle D, as in doggo, are corresponding.
Sophia Warburn won't ever let me say doggo.
She's wrong. So corresponding sides, side AB, which side is that congruent to? AB is congruent to side FE. Very good. Side BC is congruent to what side? DD. ED, very good. And side AC is congruent to what side? FD, very good. So if I put this congruent statement, if I put triangle, we'll have to fit a lot in here. If I put triangle, if instead of calling this ABC, I call it BCA. What do I have to call my next triangle?
EDF.
Okay, Noah, how would you say, why did you say EDF?
Because it's originally ABC. When you move it back, then the other one has to move to the back.
Okay, so because I moved kind of A to the back here, I put it behind angle B and C. We also do the same with F because they correspond. We could also say that because this one starts with B, this one has to start with E, because B and E are corresponding angles. Because the second one is C, which corresponds with E, or D, excuse me, D has the second. And then A corresponds with F, so they have to be last as well. So you put them in order of which they correspond. So the order of the second one is dictated by the order of the first. You can put the first one in any order, but the second one has to match it. So it's put in order of corresponding. Okay? And now what if I put CBA, triangle CBA, raise your hand if you can finish the other one that would match that. Haley.
It would be
DEF. I agree. If we put CBA, well, C corresponds with B. B corresponds with E, so we put E second, and A corresponds with F, so F goes last. Questions on that? Okay, we're gonna go ahead and move right below this.
Wait, hold on. That was what happened?
She said, "Wait, hold on."
I literally
Wait, hold on.
It's a good thing I'm gonna go nuts.
See, that's a funny one.
I like
I gotta go nuts. Mr. Carlson.
Aubrey's gonna start talking in third person.
You keep saying that, we always forget.
It's a great idea.
I know.
Riley.
I came up with that.
Aubrey already does that though, so.
I do it sometimes.
Jacob came up with
It's
that.
really hard.
Aubrey, shh. Then people are like, Aubrey, why are you talking about yourself?
Hey,
You guys are gonna make
Okay.
Noah kill himself.
Aubrey.
Identifying congruent parts. Okay, so we're gonna work on filling in some congruent statements. What I want you to do is I want you to fill in these three on the left. So these blanks right here.
I don't see three.
Like this first one, the second one, the third one.
No compromise.
It's supposed to be a code word.
Is that a three
No,
or
okay,
like?
it's a bracket. Okay, it's a bracket.
Is it
Happy, it's a bracket. No. No. That is a fine bracket, darn it.
I'm only so good at brackets and it drives me nuts. I'm horrible.
So am I. I'm
It
good.
looks like It looks
No.
like a man with mustache. Like one of those ones that just goes like this. And the nose and then the mustache. and the
Hey,
chin.
hey. Are you guys finishing these three?
No, because I don't even see the triangle.
We used to argue with Miss Jones on whether that was a brace or a bracket because she called it bracket. We're like, that's not a bracket because this is a bracket. What am I doing? Oh, that's what you're supposed to do. What?
That's how you make a bracket right there. Yeah, just like mine. Look on you, Liz.
Oh my gosh, Kaylee, look at this amazing tilde that I made.
Kaylee, don't forget your tilde.
I know, it looks great. I'm really proud of it.
I think that's just gonna be a trend for every test.
I'm really proud of it. I'm Mr. Carlson. This is me. I'm there first.
Aubrey's really proud of it. Aubrey is really proud of it. already done 3 seconds after she walks into the door.
Change classes later.
Aubrey's thinking about it.
I do my second semester without you
I do.
before.
Yeah, you gotta do it before. But you can't switch unless you're failing or you're a senior. I feel like that's gonna like fly off the pit into my face.
I was trying to eat it over there.
That was the
Oh, that's
second.
what I was gonna tell you.
I know.
So my brother is a 6th grader and he goes to Pottsville.
Yeah.
And I guess the teachers had so much trouble with kids yelling out "yeet" in class that it is now banned.
Didn't they ban Fortnite too?
At school, I don't know. He was just telling me, it was like 2 nights ago. He was like, yeah, they banned yeet at school. Because they started laughing so hard. He said, so they get, he called it a DSS, but I don't know the official
Yeah.
name for it now. If it's still,
Yeah.
At St. John's, they banned flossing.
Wow.
Yeah, so it was like anytime someone says that the teacher just pulls one out and makes them write it over their class.
I would just think.
Okay, can I get a volunteer to do some of these? Joe, Josie.
The whole class would just stand up and just say,
Can I just do the first one?
Sure.
Alright.
Yeah. How that one?
Can I do the second one? Mr. Paulson?
Sure.
Fix the bracket.
No, it's fine. It's beautiful the way it is.
Yeah. I'll
You're
get
a
back
big
to that
Joel.
feelings too.
That's why I hated that.
Yeah.
Like you're 6 rounds of less.
It's gonna need some.
Now my arm's colorful.
Where's the bracket?
It's very nice. Good job.
Actually, I think it's better
Hey,
this way.
Josie, be honest with me.
Wait, that's,
I feel like that's the rat.
Oh my god.
Yeah, that'd be right. Okay. Riley, go ahead and do the second one.
Sorry, I didn't mean to research
It's like
it.
a bird with
Is
a
that
really
rat?
long
Hey,
neck.
Josie, be honest with me. Were you the rat?
No.
You didn't. You weren't?
No.
Okay.
Beautiful, Riley.
I think that
You
was
didn't
fake.
do
It definitely was.
I thought she was
Why?
gonna
Why?
I feel it's going out there.
She was quiet the entire class.
She's not quiet.
Did you realize that?
Yeah.
She was quiet the entire
Oh,
class.
we're talking about she was trying to
No,
keep us
you're
like
doing
front
too many.
No, go ahead and do
What
it.
happened?
No,
No.
It is her.
What happened?
It is.
Okay.
Nothing.
You got
You guys won't know until next year.
You have to share with some of the class.
Yes, Jaylee? Yes, Kaylee? Sure.
Sure, it doesn't before though.
Oh, we were supposed to do all
Do you have shoelaces?
That's okay.
Yes, Josie.
You just find out.
It's okay.
I thought you did. She did.
And then I got her and I was like, oh wait, she didn't do that. Right, and then I saw you did sabotage, but it's back.
Oh, I
And
want.
then you did that, you had it, and if you got caught with it on there, you had it answer like an extra question on the next quiz. So
I'm gonna be
and
real.
if you get the rat, and if you guess the person who's doing it, you get an automatic 100% on your next quiz. So we're all sitting there and we're talking about it, and then Faith keeps like changing the subject, and we're like, Faith, you're the rat, because that's what Mr. Schuler was like. We're gonna call it the rat. So we're like, Faith, you are the rat. She's like, no, I'm not. But she was quiet. She entire class did.
And she sat in the corner.
And she sat in the back
She
corner.
was just like, what are we talking about?
So,
Oh, wait. Hold on.
Ran
Oh,
out. She was.
funniest
In
thing is
return,
ever was Ben had to spell sabotage backwards.
Duh.
Ben was
Come
like,
on.
And we live in a whole
DKD was
world.
Get over your
forward.
level.
Forward. You spelled it right.
He spelled it right.
Really?
Yeah.
We have so. Oh, I wrote something.
Come on, come on. Yeah.
Right.
Yeah.
Red right. Red right.
I was gonna go see Aya. I'm going to see a Christmas film. I'm so
Okay, voices off. Everybody look up here. Anybody have any questions or disagreements with what's up here?
Yes. Yes.
What's your disagreement?
CA, the one that's like with that one.
Okay. What do you think it should be?
HF.
HF. Okay. Are they the same thing? Are
Yeah,
HF
It's the
and
same thing.
FH the same thing?
yes, because
Because they're
they're lines.
line segments. You
Oh,
can flip the order of line
I
segments.
said
Okay.
no.
Fight
But-
me.
That's a good point, and it's also good to talk about that they are the same, but it is different at the same time. So it works just like it would, even though it's different than what you have. Okay. Cool. Any other questions on that? Okay. So without drawing the shapes now, if you don't have any triangles, try doing those 1 through 6 at the bottom there. They're on the right side of what we just did. So please do those.
What?
Oh, I got it.
Hold up, how
I got
Wait,
this.
just the sides is the weird part.
Someone didn't put the lines above these.
Yes.
I'm very upset.
No,
I'm very upset, Jacob.
Nice, nice.
I can't do them anymore.
Jacob, remember that? This morning in biology, no.
Oh, yeah.
I toasted Jacob.
Yeah?
It's so good. I kind of felt really bad though. I'm sorry if that.
You can tell everyone. I don't care.
What was I saying? He said something to me, and
It wasn't mean or anything.
no, he was just like, "Hi, Riley" or something, and I was no. You called me funny, and I said your face is funny, or your face is
I don't
a joke,
understand
something
how
like that. And then the whole class just erupted.
It was yourself.
So which ones would match B and C in the first one?
Not Austin, I did this right.
Alright, Daddy.
It was just so funny. His face was so happy.
Can I get a volunteer to fill these 6 in?
I'll do one.
Noah. Fill the first 3 in, engage will fill the last 3 in.
Phil.
So fill 1, 2, 3, engage will fill 4, 5, and 6. Where are we going? Oh, yeah.
Where we drop more of these.
Yeah. See, so, but I'm not sure.
Yeah.
Yeah, I was like, I can help.
Okay, so like, you know how like you have your like pie and like I do.
Mr. Castle.
So my dad had his own little dad joke, and like everybody used it, but he used it more than often. And he would go, cause like if someone hurt themselves, he would say, "Does your face hurt?" And if they said no, he would say, "Well, it's killing me." And so he like always said that, and he stopped now. Thank God.
Ooh, that's a good one.
My brother was
So
like
sad.
another brother.
Okay. Very good. I believe I agree with this. Let me check real quick. Yep, I agree with all of these. Anybody disagree with any of these?
Hold on, let me write them down.
We just say, yep, there's letters.
Yep.
There's so much letter.
Josie.
Could I just put YT for the number 4 too? Even though the back, I know they're the same.
Yeah.
East of.
I have questions though, like how do you get the line segments? 'Cause I don't know.
Okay, Gabe, explain how you got the light segments. You did 2 of them. Explain how you got them.
Because when you do TY or CM on the first thing, the triangle, and you look at them, it says NBC and YRT. You put that over to TY on the other one, and they equal each other. So C is the last one, and M is the first one, so then you know that T is the last one, and Y is the first one. So it's that.
Can you match them
Whoa.
Did I answer your guys' question? Dang. Okay, so we're gonna move on right below this.
I will anonymously report you.
Was it just for like a?
Everyone was saying how we should honestly report having us on. Yes.
Okay. Determine whether the given triangles are congruent and let's explain. So if they're congruent, we would need what to be true? All corresponding sides and all corresponding angles to be congruent. Okay, so let's go through this. Is there a 90-degree angle in this one right here? Okay. So is there a 90-degree angle over here? Okay. So we know these are congruent. What about an angle? Do we have a 30 degree up here and a 30 degree down here? Okay, yeet. So that matches up. And what about the 60 degrees? We have that here and here. Okay, so our angles match up. So we have our 3 angles. So now we need the sides. And more importantly, we need the sides to be corresponding, meaning they need to be in the same spot. So GH here, or between the 30 degree and the 90 degree angle. So we can look at this. Okay, between the 30 degree and 90 degree angle, what length do we have here? 7. Okay, so between the 30 degree and the 90 degree angle, what do we have here? 7. Okay, so those are corresponding. 1.7 meters and 1.7 meters are corresponding there, and they're congruent. So that's good. Okay. What about between the 60 and the 90s? What do we have? 1. Between the 60 and the 90, we have 1. Do those correspond?
Yes.
Yeah, they're in the same spot. So we'll put 2 tick marks there for being congruent. And then this 2m between the 30 and the 60, is this 30 and 60, is this 2m as well? Yeah, so those are corresponding and congruent. So are all corresponding parts of these triangles congruent? Yeah, so we can say, we can make a congruent statement, so we can say triangle GHJ, is congruent to triangle what? How would we word the second one if I started it off as GHJ? Very good. KLM. We'd have to start with a 30-degree angle and go to the 90-degree angle, finishing off at 60-degree angle. And we could say because all corresponding parts
Are equal.
are congruent. Hi, funny, I'm Mr. Gossel.
Jacob's done.
I also don't like writing capital letters. Yeah.
You've heard that.
That's why I'm writing all capital letters instead of starting my dominant zone.
Sounds very
It really does, though. It sounds like a group problem. Yeah.
I don't understand. I never why.
Makes 2 of us.
I like blue.
People. I like drawing capital letters.
Spells bad in your
What?
It smells bad in here after the word vomit.
No, Monday I could write a speech. It was almost like I could think.
Alright, questions on that first one, class? Questions on the first one, class? Okay, I want you guys to try the second one real quick.
Can I just
Alright.
How am I supposed to know?
Okay, they just kind of
the angles are congruent if I don't know it.
Okay, we'll start with sides.
Just kidding. I know.
Wait, why is it funky like that? Like, one, the angle on this one, like, not the angle, the side is 8.5, but on this one it's 8.4.
Wow, it's like you found something.
Dang.
No, it's just like all quiet over there.
I just wanted to. I care no more.
I will anonymously report. I think you will. And you all know who it was.
Can't say my normal word because that's normal sentence.
That's a box, not a triangle.
Okay. Adrian.
White has a reception.
Hey, voices off, everybody. No, why not?
Cause,
You can just circle the problem. It's kind of rude.
circle what?
The problem. What makes it not?
Oh, cause these sides aren't congruent, and so that messes up.
Yeah, because that one pair of sides aren't congruent. We need all of them to be congruent for this to work. Because one side is not, it doesn't work.
You mean me saying, oh wow, I can't believe, I think you found something.
I didn't know
Didn't
that's what we
point
were
out the
trying to
answer.
do, so.
That was kind of fun.
Okay,
Determine
Yeah.
the given triangles that's congruent.
questions on this? Questions on this?
That
It's
triangle
okay.
has a C.
Sometimes it is out.
Okay, we're gonna move on. So next page.
I find it kind of lame. I just think of because I was like, I didn't know I taught.
Okay. So if we're given that triangle ABC is congruent to triangle DEF, find X and find Y. Go ahead and do this one on your own.
Okay, what?
If we're given those two triangles are congruent, find X and Y. Top left one.
What?
The bridge is
Oh wait.
Oh, no.
I got
Speak
it.
too fast.
No, I do not have to speak nearly as fast as Mr. Finance.
No.
Ah.
How dare you assert that about me?
You just talked pretty damn fast.
Here's the level of speed for talking.
Kevin Malone, Mr. Fossil, Mr. Titus.
Tilson doesn't even speak fast.
He just speaks once and that's it.
Yes. Why did I say Tilson speaks
Oh.
fast? You really don't speak fast.
I mean, like, watch The Office. Watch The Office. All I
Can I use my
I'm
calculator?
dead serious. I'm Mr. Castle. I mean, it's a little bit weak, but I
I know,
suppose you
but
really
I'm a
need it.
weak person.
Oh yeah.
What?
Gotta go for the
I'm Josie.
You wouldn't say the iron part though.
I'm Josie. I'm Mr. Cross.
No, you would say hi,
You're
Castle.
so close.
Mr. Castle. You would
I'm
say
Mr.
hi,
Castle.
Mr. Castle. You wouldn't say the I'm there. That's what I'm saying. That's so
Hi, I'm
great.
Mr. Castle.
You're getting there, Josie. You're getting there.
I'm tired.
Slowly but surely.
I'm sorry, Mr. Castle.
No, I was gonna do it.
Okay, go.
Hi, guys. Shake my hand.
Whenever I do it, I
I
go, hi. Whatever they said. I'm Mr. Castle. Because I'm doing it like a dad joke when you're like, hi, I'm dad. I always say it. Yeah, my
Hey, does anybody want to do this one up here? Oh, and you
I'm
sound
not
good
done
about it.
yet.
Okay, let's go. You got it?
One left.
What? Yeah, one on the left.
I was
Well, like,
like,
where's my
my
Bible says I'm Victorian history, and then I colored it now.
Oh, dang. That's pretty.
My brother. I always say
These are my arms. They're pasty.
Your
Your arms are
Oh.
pasty. They're pasty. Look at that.
Tasty.
They're pasty.
I've never heard somebody describe their arms as tasty.
Oh, yeah.
Gosh, look at that.
Everybody looks
Easy in your skin.
fight.
I love how Kayla screams. You're pasty.
Dude, the only thing anyone can
Yes,
describe my
please.
arms
The
as
Mr.
is
Ward yelled at me yesterday
swole.
because it showed my eye.
Don't you forget it, Gage.
He was making fun of me, so I ran after him. He started running out the room because he knew I was gonna chase him, and I said, "Fight me!" And I yelled, "Fight me!" at him, and I started running after him. Mr. Ward was like, "You need to calm down."
I tell that to Kaylee all the time.
Yeah,
she'll
she
yell
does.
at me and then she'll be like, calm down, Kaylee.
Yeah, because you do need to calm down.
Thank you. Kaylee's gonna fight. She'll constantly yell at me. She'll be like, stop, calm
Okay,
down.
boys, stop. Anybody disagree with what Owen says? Does anybody disagree with what Owen wrote?
What's
No.
more? She's like,
21. 21.
Yes, I do.
Why do you disagree?
Oh, because I'm stupid. That's why.
You're not
I
stupid.
said-
You're awkward.
I'm Jacob.
You're not stupid. You're awkward.
oh. I did. I'm just kidding.
I don't disagree.
Okay. Does anybody actually disagree with Owen?
No.
Okay, good, because he's right. Okay. So, hey, we're gonna talk about our third angles theorem. If two angles of one triangle are
That says
congruent,
29.
if two angles, what did you get?
It says 29.
Pass that, Kaylee. Okay. So, 2y minus 8 is equal to 50. You add 8 to each side. 2y is equal to 58.
Oh.
Okay.
I keep. That didn't look like.
So now, Kaylee. When I say, does anyone disagree about 3 times, that's your chance to say something, okay? So, third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, which is what we have here, then the third angles are also congruent. Now let's think about that for a second, okay? If these two have the same measure, and these two have the same measure, let's just give them some random numbers. So, someone give me a measure for angle B. 11, okay? Someone give me a measure for
17.
angle A. 17, okay? So if angle E is what then? 11 is the same as B, and angle D is 17, okay? So this has to add up to 180, right? So this is 152.
Yeah.
This one, you do the same thing.
But if you already know the other two are congruent, then why would you do all that?
I'm just showing it. I'm proving
Wait,
it.
how do you know
Okay?
it's 17?
We gave random numbers to it. We gave random numbers to it. Voice off. We gave random numbers to this, and we said, okay, if we let's just give it any number. Let's give this any number, and we add them up. We know this is going to be 152 from our triangle sum theorem, and we know this one's also 152, and they are congruent. So as long as we know two of them are congruent from each triangle, then the third ones have to be congruent. Does that kind of make sense? Okay, anyone confused about that?
Sense for sure.
They think. So Think
Yeah.
means must do means, you know? Okay. So we need to do this extra example for, okay? Find the measure of angle YXW.
105.
Okay, so this is kind of a weird looking thing. So what I do when I get shapes like this, what I recommend you do if this is kind of confusing to you, is to split the triangles up. Okay, so we kind of have a triangle here with W, X, Y. And I'm also going to do this triangle with X, Y, and Z over here. So notice how X and Y are repeated because I kind of took this triangle and it's like I split it apart. So it's like I took the overlap and I split them apart now. So this angle, this YXZ is still 35 degrees. And it's still congruent to this angle of WYX, which is also 35 degrees then. This angle down here is still going to be 40 degrees and congruent to this angle down here.
Which would equal to 75.
And so these add up to be 7. First of all, is anybody confused about what I did with splitting up the triangles? Does anybody need me to back up there, okay?
Why is on the left one? Why is the 35 on the far right?
So here, if we take this triangle, this was angle YXZ, correct? Okay, so we made it YXZ. Well, we know this angle is congruent to this angle, which is XYW. XYW is right there. That's why. Yep, good question. Okay, so Ian said, hey, this 35, 70, and 40, that adds up to 75 degrees. How does that help us, Ian?
You know the triangle equals 180.
Okay.
So it would be a 105.
So we know the whole triangle equals 180. We should take away 75 from that. And we know this third angle is 105 degrees, okay? So that helps us with this one. And how could we find YXW? YXW? They're the same thing by our third angles theorem because two of the angles are congruent from these triangles. And we know the third angles are congruent, making this one automatically 105 degrees. Questions on that?
Yes.
Yeah.
Why do we know what angle we're doing?
Because it says it up here.
Yeah.
Let's see what's
It
going
says
on.
3 points.
Yeah, YXW. So we can name angles by 3 points if we recall. And the middle point is the vertex. So X is the vertex, and it goes in the direction of Y and W. So the only one that goes in the direction of Y and W and starting and meeting at X is right here. Oh, sorry, right here. So we're talking about this whole angle there in the blue. Does that make sense?
Yeah.
Okay. Any other questions on this one? Okay. Okay. Oh, Matthew McConaughey. Hey. Okay, we're gonna skip these two examples.
Dang,
Dang, we
Oh
don't need
my
education.
goodness, thank you.
Cross those out.
So we're going to theorem 4.4?
We're going to theorem 4.4. Okay. So reflexive property of congruent triangles. Well, I think you might know what this means. What's reflexive property mean? It's the same thing. It's not flipped. It's the same exact thing. So triangle ABC is congruent to triangle ABC. It's congruent to itself. Well, that makes sense. Something would be the same measures as itself. Okay, or in this case, the same size and shape. Okay. Symmetric property. What's that? Which one does that do?
It's the same thing, but like.
That's the same one, but flip. So if triangle ABC is congruent to triangle DEF, then what? Triangle
There's like
DEF
700
is
people
congruent to
talking
triangle
right now.
ABC.
Triangle ABC.
1, 2, 3, 4. 1, 2, 3.
Okay. Transitive property. Well, that's the one where we link them through. So if we have triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle JKL, Riley, what do we have?
Triangle ABC is congruent to triangle JKL.
Very good.
Wait, that's my initials.
Okay. So triangle ABC is then congruent to triangle JKL. We take out that middleman, triangle DEF. Questions on those three things? Okay, these are really just extensions of what we've already learned these properties to be. We're just applying them to triangles now.
Triangles have
Try and care,
sides.
Aubrey. Try and care.
Shakes hurt, you know.
They hurt me.
Okay,
No play.
so in this triangle, in these two triangles, okay, we have two triangles here. We have this triangle bottom left, and we have this triangle on the top right. Okay, so we know that angle E and angle G are congruent because they're both what? 90 degrees. Okay, they're both right angles. These are congruent. We know this angle, GFH, is congruent to angle EFH, right? Oh no, sorry, EHF, because they're the one arc. And we know these angles, EFH and angle GHF are congruent because of the two arcs. So we know all three pairs of corresponding angles are congruent. So now we need all three pairs of corresponding sides are congruent to show that these are congruent triangles. So we have FE, the one going from two arcs to 90 degrees, being congruent to HG, the one with two arcs going to 90 degrees. So that works. So those correspond. That's good. Two congruent arcs. And then we have FG, 90 to the one arc, and EH, 90 to the one arc, being congruent, which works as well. So now we need FH. What do we need FH to be congruent to? With FH. Is FH congruent to FH?
Yes.
Because it's the same thing. Which property would we be using to say that FH is congruent to FH? The reflexive property of congruence. Very good. And so because we know that to be true, if it's the same thing, we can just show 3 marks down the middle. So we already did 1 mark, 2 mark. So you don't have to do like 6 marks, for each of them. You can just do 3.
Weird flex, but alright.
Okay? So we can say that triangle FEH is congruent to what triangle?
FEH is
That's
congruent
true.
to FGH. No.
Okay, so if we started with
HGF.
HGF, good catch there, Aubrey. Why did you do that?
Because I realized I had it wrong.
Okay, you realize you had it wrong. So if we started with F here on this top right triangle, we had to, because that has the 2 arcs, we had to start with the one with the 2 arcs in this bottom right triangle, which is H, and then go to the right angle. So we have to go in the same order there. Questions on that class? Hey, yes, we are going on to that next page. We're going to do the distance formula. I know we missed this. We missed the distance formula.
No, we don't. You don't listen to
H missed it. Okay. Hey, who can remember what the distance formula is? D is equal to. Evan, you got this?
Negative B plus.
No, that's quadratic formula.
Oh, frig, that's the wrong song.
Can anybody help me with the distance formula? Noah.
A squared plus B squared equals C squared.
So that's Pythagorean theorem.
I never heard of it.
It's
Distance over rise. Rise and
Was it like both divided by 2 or something?
No.
Don't tell me I'm
No,
gonna
that's-
y1 minus x minus
X1.
No, that's.
x. Oh,
Oh yeah, this
Oh,
x squared is gonna come
X
over
two.
on with the sum.
minus
X
Oh.
minus 4
X1.
Minus x1. Parentheses plus.
plus
Or squared.
no squared plus
Parentheses
parentheses
y2
y2
minus
minus
y1.
y1
Doing
great,
squared.
That's our distance formula. Write it down.
Yeah.
Okay.
The obvious
You
song.
remember
We need a
that?
song for that.
Okay. Yeah, Aubrey, you're gonna come with the song.
Yeah.
No, do not make a
Do any
song.
other distance
Do
make
not
a song.
make a
Then I'll record it. Don't worry. Hey, don't worry. I'll
D
before you
equals
do
RT.
it, I'll make this song and then I will
Anonymously.
Yeah.
Do it before you can pronounce it right.
You don't hurt yourself.
Enemy spotted.
Okay. So we need to determine whether these given triangles are congruent. Okay, how can we figure that out? Well, we have to make sure all their angles and all their sides, the corresponding angles and corresponding sides, are congruent. Okay, well, do we know any of the angles on these triangles A, B, C, and D, E, F?
Yes.
A, you know
Okay,
A.
we know angle A is 63.4.
F,
We know F is 26.6. Are there any others we could know?
A, B, C, and F.
Okay, you're saying
No,
angle
G,
B. What do we know about angle B? 90 degrees because it makes that corner. Okay, what about another angle?
E.
Okay, this angle, angle E or DEF is also 90 degrees because it forms our angle. So those congruent? Okay, perfect. What's going to be the third angle in this triangle? How can we figure that out? Okay, how do we know that though? Can we figure out what this measures?
Because E,
You use the
the
distance
distance
formula.
between AG is just equal. The distance between AG is
Okay, that's not quite how. That's not quite how we figure it out, okay? So, if we know this angle to be 63.4, this angle to be 90 degrees, how could we figure out this angle at the bottom? What do all the angles in a triangle add up to? 180. So could we take 180 minus 63.4 and 90 and get this third angle? Okay, so minus 153.4 and get 26.6. Okay, what's that look like? It looks like the same thing as over here. So are these congruent? Okay, and these two angles are congruent. So by our third angles theorem, if 26.6 is congruent to 26.6, 90 is congruent to 90, 63.4 is congruent to this angle. Okay, because we have two sets of corresponding angles congruent, we automatically know the third pair of angles is congruent. That's our third angles theorem. That's when we walked through and I was doing the numbers and you guys are like, why are you doing the numbers? We'll get there. Okay, go ahead, Evan. Fill that page. Okay, so we figured out corresponding angles, right?
But we have to figure out size.
Now we have to figure out corresponding sides. Okay? We figured out corresponding angles, now we have to figure out corresponding guys. Guys, we need your voices off. Thank you. Okay? So let's start with side AB for grins and giggles. What's the length of side AB? 3. How do we know that?
Because we can count.
We can count, okay? What would side AB have to match up with here? ED. What's the length of this one?
3.
So far, so good. Let's give that a tick mark, okay? What about side BC? What would that be, the length? 6. How do we know that?
We can
We
count.
can count. What would that match up with on this one? EF. What's the length of EF? 6. Does that match up? No. So let's give that 2 tick marks. Now we need this third angle.
Since it's if there's two sides congruent,
Okay. Ian, what are you saying?
since there's two sides congruent, then BF and AC can be.
We don't automatically know that right now.
Because it's only one to do angles.
Okay? So we can do the distance formula and figure this one out. Figure out the point of this, saying this is at -4, comma 3. And this is at point -1, comma -3. So we can do that. So let's go ahead and walk through that and do it here.
So
So
how-
distance for AC, yes, Ian?
So how can it like our what we just had down? We wrote down if two angles, why can't that become lines? Like, if you have
We don't, because all the angles have to add up to a certain measure,
right.
but all the sides don't have to add up to anything specific. Does that make sense?
Yeah, but if you
Sides can add up
If
to
it's-
anything, but
I
angles
know, but
have
if,
to.
if what E and D are the same length,
Yep.
and E and D and A and B are the same length, and B and C and E and F are the same length, they're gonna make the same thing.
We would know that later. We're gonna learn that actually Friday and Monday, because of the angles and the sides combined. We can know that, but for what we would know right now, we can't know that. So we're gonna go the long way, and then we'll learn that you're right in a few days.
We'll learn that you're right.
Okay.
You'll learn that you're currently right.
You can't know that. Right?
So someone help me plug this in and set up the distance formula. Kaylee.
Okay, so it would be, let's do 3. We're not 3. Let's do -4 minus a -1 in parentheses square plus parentheses 3 minus -3 parentheses square.
Very good. Okay, so now we're gonna complete this. What do we have when we have 2 negatives in a row? Positive, 2 negatives in a row over here. Positive. Very good, Aubrey. What's
She
I'll
doesn't
just say
sound very
negative zero.
positive. if she
What's
says
negative
positive.
4 plus 1? What kind of 3?
Negative 3.
Negative 3, but we put it in parentheses and we square it. What's 3 plus 3?
6.
6. We put it in parentheses and we square it. So what's negative 3 squared?
9.
9. Positive 9. What is 6 squared?
36.
36.
Why did you
Wait.
hesitate?
If I put the negative 3
I thought you
first,
said
okay?
86 at first.
If I put the negative 3, like I did it with the opposite of
You did the y's and then the x's? Okay.
What? The y?
Did you have your negative 3 at the back or at the front?
I put, what did I do?
Oh.
Because, like,
So you did your x's, yeah.
well, I put this one as x1. So that would be
Oh. So, hey, what Ian's saying is, hey, could we mix the orders of these up? If we put this x first, do we have to put that y first? On this one, we don't. On this one, as long as the x's are together and the y's are together, that's what matters. Is that your question, right? Okay. Let's see what you found.
Yeah.
Okay.
Yeah.
9 plus 36 is 45. Okay, so the distance of this is the square root of 45. We could simplify that. We're not going to right now.
6.70820393.
Well, aren't you
Try hard.
Okay, or is 3 times the square root of 5?
Why would be 3 times the square root?
Or you just leave
Because
it
you
at
can factor it.
Because this is the square root of 9 times the square root of 5,
Yeah.
which is 3 times the square root of 5.
You'll learn about it in algebra too.
I
We'll use
learned
it for
about that
next
in
time.
algebra
I was
one.
gonna
Okay.
say you should have learned about it in
Yeah.
algebra 1.
So, voice it off, voice it off, voice it off. So this is 3 times the square root of 5 or the square root of 45. Hey, on this one, did we have to use a distance formula, by the way? Someone was saying we could use something else. What else could we have used? Pythagorean theorem. It's a right triangle. We can use the Pythagorean theorem. Okay. A2 plus B2 is equal to C2, like that?
Squared.
Squared.
Oh, you meant squared. Okay, you told me 2. A squared plus B squared is equal to C squared. Okay? So I don't see an A, B, or C on there. Where do those come from?
So your hypotenuse is your C, and the other two sides are A and B.
Okay? Hypotenuse is C, the other two sides are A and B. Does it matter which one's A and which one's B?
No.
No. Okay. So I'm going to pick 3 as the A, one of the sides, square it. 6 as the B, one of the sides, square it. And it's going to equal our C squared, the hypotenuse that we're trying to find. So 3 squared is 6 squared is 9 plus 36. How do we solve for C now? You square root both sides because the square root of C squared is C, because C times C is C squared. Square root of 45 we said was 3 times the square root of 5. So are these the same? So are all corresponding sides and corresponding angles congruent? Yes. So are these triangles congruent? Yes. So we could say triangle ABC is congruent to triangle what, Evan?
Triangle EDF.
Try again. ABC. And what would you have to go from there?
Oh, DEF.
Very good. DEF. And we would say because, same reason as we had earlier, because all corresponding parts are congruent. I know it's a bit long. We have to write this one out. Questions on this one? That was a bit of a lengthy one, Jacob.
Which formula do you recommend on the ACT? Or our homework, I should say.
If it's the right triangle, always Pythagorean theorem. But if it's not a right triangle, then
Sax to sax.
then you have to do this. But if it's the right triangle, Pythagorean theorem is way easier. Like not even close, like way easier. But if it's not a right triangle,
Are you only gonna ask us on our homework?
Well, you just do the one
Are
thing
you gonna
that
ask
you
us on
know.
our homework?
it doesn't say a specific one, no.
Okay.
I was so
Hey, just guys, did you know that 9 plus 10 is 21? I saw a video.
Oh, that is.
Talk about
Are you
old.
joking with me? That is actually 21.
What?
Like
Yes,
videos
there's
of
actually-
that.
The video is perfect.
Videos.
Did you just watch it?
What?
Did you just watch that video for the first time?
I
Oh, it's a good one.
I've never seen it.
So So if you ever hear me say 21, that's where that comes from. You're stupid. No, I ain't. You're stupid. No, I ain't. What's 9 plus 10? 21.
Oh my god.
No, like I knew what the video was, but I've only heard like that much of it. I didn't
What's
hear the
that plus 10?
explanation part.
Wait, I've never seen it.
Explanation.
Yeah, there's a video of like a math professor explaining how it actually
Yeah.
equals 21.
Great.
Unless you're using a different number system, I completely disagree so far.
Can we
Okay,
watch
hold on.
it?
I think I remember what it was.
It's like
Hey, 1 second before, Aubrey, 1 second before we do that. Thank you. Okay? Hey, instruction. Don't do. I know. 5, 7, 9, and 11. Those are the ones not to do. I don't want you to do those.
9
I.
and
Okay.
oh, it's not.
Ms. Swink.
That's like blind out.
Josie, what's your time?
Schwank.
Alright. Anyway, okay, so you have 9,
Mr. Consul,
you have 10.
made enough to go to. I'm pretty sure.
Yeah.
I'll check.
Wait, hold on. What was it? I don't remember what.
3 times 2.
Oh, that's not how the math works, though. That's not how math. That's garbage. No, it can't.